Part 2, we're going to take a look at three particular properties, the product, quotient, and power properties. Again, massively important topics for all future math work that we're going to be doing, not just this year, but in your future courses as well. And this is just going to be a run through on the notes. I'm going to definitely have to do another video before we get to this unit on the proofs of these. And I'll do a little bit of the proofs in the class as well. Even though this is not a proof-based course, you may have the option of taking that next semester or next year. Okay, so we're going to take a look at the product property. So the product property is based upon our old exponent rules. Remember, they're like kissing cousins here. We have a to the m times a to the n is equal to a to the m plus n. All right? So basically, when we look at this in log form and we see two logs of the same base being added together, we can rewrite that as one log with the same base times those two components right there. So here's an example. So we see these two little logs right here, and same base 10, base 10. We can multiply these two together and get 15. And it's implying that we can also expand this out into two different products of 15. It becomes very useful when we're trying to solve some complex numbers. So here we have two variables, natural log, so same base, and we can break this up into ln u and ln v. And here we have another two variables, the exact same thing. Okay, so let's go ahead and I could break this one further apart. I could do ln of 3 plus ln of x plus ln of y. So let's take a look at the next property. This is going to be the quotient property, and this goes again to where we have a to the m over a to the n is equal to a to the m minus n. That exponent rule, so it's very much tied together. So we're going to be dividing exponents. So when we divide like this, we can turn this into a subtraction, make it much easier to work with. So here's some examples again. We're going to take a log 5 and we can turn that into 15 divided by 3. So we just make that into a subtraction. Same thing here. We can divide this out, and I can even break this up using our product property. And again, here's another example over here. So it's always best to learn by doing. We'll get to that in a second. Here's the power property. Now this proof is going to be a little tricky, and it has to involve substitution. And again, if I'm going to rewrite this course, I'm going to change these letters, change that to B and some more of the other ones, because in the proof it can get confusing because U's are just not my favorite letter. I don't know why U is not my favorite letter. I guess I'm being mean to the letter U. I guess it's just one of those weird things. I wonder where U came from. I'm sure it's tied to W. I have to look that up. All right, anyway, moving on. So what we have here is log base A u to the n power is equal to n log A to the u. And what's going on here is we're bringing this here. And if you, I know there's some viewers that are familiar with calculus and say, hey, I recognize this because you're looking at derivatives. But not quite. There's going to be a relationship further down the road. Absolutely. But basically, we can take the power and move it to the front. And I would definitely have to do a proof on this. It involves a little bit of substitution going on in here. Basically, I would take let m equal to log of, say, a u, and I'm going to substitute m for this, and it would imply that a to the m is equal to u, so on when I convert it to exponents. And then I would play around with it, and I would get this right back to here. Not a short proof. It's not too bad, though. So here's an example. I have raised to the second power here, so this 2 would come right to the front. This n would come right to the front, and so on. This 7 would come right to the front. So let's go ahead and play around with what we're going to do this. And this is expanding logs. So I can break this up into a couple of different things, but I'm just going to split it right here. I'm going to do log base 10 of 15, and since it's product, I'm going to do log. I'm going to add right here log x. Here we're going to use our quotient property, so I'm going to subtract. I'm going to do log 3 minus log 4. And here I'm going to use my power, and that's just going to go right to the front, and I'm going to have 4 log x. My cat wants to come up here and play. I'm not going to let them. Kitty, kitty, kitty. So this one, we got a little bit of work to do. We got a lot going on here. First thing I'm going to do is I'm going to use my exponent rules, definition, not rule. And I'm going to put x squared y cubed and raise that to the 1/3 power. Guess what? That's going to the front. So I got 1/3 ln x squared y cubed. And guess what I'm going to do here? Of course, I'm going to expand it out. I'm going to do, you think we're done, but we're not. Watch this. I'm going to do a little bracket here. ln of x squared, and since we're multiplying, I'm going to have to add them, okay? And ln y cubed. Yep, you see it. We're going to move the 2 in the front. That's exactly what we're going to do. So 1/3. When I say expand, I want you to fully expand. ln x, and then that 3 is going to go right to the front. ln y. Now we got her, all right? So that's a full expansion. So again, turn that into an exponent, move the exponent to the front. We got multiplication going on, so we're going to add, and then get these exponents to the front, respectively, there. So log 4 x squared minus 4. Okay, what's going on here? Well, guess what? That's a difference of 2 squares. Let's play with that. So log 4, that's going to be x minus 2 and x plus 2. Yep. I got some multiplication going on here, don't I? Okay, so let's take care of that. I'm going to do log 4 x minus 2 plus log 4 of x plus 2. Kind of knocks it out right there. So look for these little things as well. Okay, let's take a look at another type of example, what we can do. We're going to condense. We're going to go backwards. So here I recognize that these two things are going to go up to the top here. So that's the first thing I'm going to do. I'm going to go ahead and write it as log x4. x6, silly me, plus log y. I'm watching my cat. 4. So what's going on here? That's a plus. Guess what I get to do? Same base. So I'm going to do log of x6 y4. Knock that puppy out. Alrighty. So moving on, and let's take a look at a more interesting example. This puppy. All right, a lot going on here. Well, I'm going to clean up this first. All right, and then I'll move my exponent to the top. So I'm going to have multiplication going on here because I'm adding. So I'm going to have 4, and I'm going to have ln, basic L. Thank you very much. There we go. That's an L. It really is. And I'm going to multiply z. Why did they give me z's? Z plus 5. There we go. So that's just going to be z squared plus 5. So I might as well just go ahead and write it like that. ln z squared plus 5. Got that one cleaned up. Then that's just going to be minus ln z minus 5 squared. That 4 is going to come up top. So I'm going to have ln z squared plus 5 in parentheses. That's a squared. And that's going to be the 4th power. That didn't change. And now I'm going to do my quotient rule. That's going to be divided by that. So I'm going to have ln, I'm going to have z squared plus 5 to the 4th power. Did I do that right? 5z. Silly me. There's a z right there. I'm getting old. All right. So, and that's going to be on the bottom. Z minus 5 to the 2nd power. Come on, writing pad. Be nice to me. There we go. That's it right there. Okie dokie. So we got one more to play with. And let's knock this out because I'm almost at 10 minutes. Yikes. This is a long video. Didn't mean to do that. So let's see what we can do here. We're going to solve an equation. Well, same base, same base, same base. They can play with each other to some extent. And there's a couple ways I can do this, but what I'm going to do is I'm going to use my one-to-one after I get these two puppies together. All right, so I'm going to get log 3 x minus 1, And this is adding, so I'm going to have log 3 x minus 4 times 2. That's just 2x minus 8. That's 2x minus 8. That's x minus 1. So I'm going to have x minus 1 is equal to 2x minus 8. For time purposes, I'm going to subtract x, add 8. I get x is equal to 7. Alrighty. So, dadgummit, I'm over 10 minutes. I'll get this posted and start working on the next video.